Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is the construct binary tree from preorder and inorder traversal. So by question name, you can answer that we need to construct our binary tree from this two traversal being given to us. That would be more or less the question. Let's understand what the question is telling us to do and how we can think of solving a solution to finding a solution to this kind of questions. Okay, so this is a medium level question. So we need to think properly before finding a solution or going ahead with the solution. Okay, but before starting this video, make sure to subscribe to this channel for regular LeetCode videos like this. So what the question says that you are given two integer array, preorder and inorder, and where the preorder is the preorder traversal of the binary tree, and inorder is the inorder traversal of the same tree. Okay, and then we need to construct and return the binary tree. Fine. So let's understand this example like given to us. The example being the preorder is 3 9 20 15 7, and inorder is 9 3 15 27. Okay, fine. So out of that, we constructed this particular binary tree, that is it given the 3, 9, then 20, then this null being the two child nodes of the 9, that's null, and then is 15 7 being the two values of the 20. Okay, so how can we go ahead doing that? Okay, how can you go ahead doing that? Look carefully. If you see, like when you go ahead with the pre-order traversal says that first we should visit the root file, then we should visit the left file, that's the root left, and then we should visit the right? So this is what the pre-order traversal is. So anyways, from pre-order traversal, we are sure that the first element we'll find is will be our root element, right? So in the pre-order traversal, look, the first element is 3. Once we find the 3, 3 will be the root of the whole tree. Like the first element in the pre-order will be the root of the whole tree, right? And what about the in-order? In-order says us about like first visit the left 5, then visit the root 5, then after visiting the root we should visit the right. So that's the pre-order traversal. In-order traversal. So, right? So we know that in the in-order traversal we are sure that wherever the root is, all the elements before the root will be in its left, all the elements after root will be in its right. So in such a case, how can we approach this kind of question? See, the approach will be pretty simple. Like we say, we are given this two or in order and pre-order or arrays, and the pre-order traversal implies that the zeroth position array, like the zeroth position in the pre-order, is the root of the node, right? That is what we see here over here, and then we can find this pre-ordered zeroth position value in its in order. Like how? Say we find that 3 being the zeroth position value, and now find 3 in our in order array. So in order array, we find that this 3 is over here, right? Now, when this 3 is over here, what we can do is like we now know, like once we find the particular index of our root, that is the 3 be our root, we now know that all the elements to its left it will be there in our left subtree, and all the elements to its right will be there in our right subtree, right? So all these elements are there in our right subtree in the in order, and all the elements in this left will be there in our left subtree, right? So that's what we are sure of. Now, just break the process into multiple parts, like in a smaller surveys, and this is what we will keep on doing. So we will first will find a value in the pre-order. Okay. Now, after this value we find, we will see where is its position in the in order subtree. And now from that index, all the values from the left to that index is in its right subtree, in its left subtree, and all the values from its right to the end are in its right subtree. Fine. So that's the more or less the idea behind this question. Fine. Now, what can I do in this is more like we can have this in order in a hash map. Say we just storing this in order in a hash map, so that the index and the in particular index and the particular value at that index is being stored in a hash map. Okay. Now, what will be the benefit of using a hash map? Well, it will be more like every time we come across a digit or come across a value in a pre-order, we need to search for it in a in order to find whatever is in its left or whatever is in its right. Okay. So that's what we need to do. But if we can do like if we can keep it in a like a hash map, then we don't need to search for that particular element in our in order array. Okay, then we simply can find an index with just from the hash map in order of one. Okay, so that's how you can like improve your code by using hash map. But you can also do the same thing by continuously searching the element. Once you get an element, search the element in our particular in order array, and then find its index and move on with the next steps from it. Okay, so that's what the idea behind this question. Fine. So now let's write this code and let's find like a solution of what we are thinking of. Okay, like well, let's find how it will look like of what exactly we are thinking to of it to work like. Okay, fine. So as I said, we will use a hash map for this purpose, and we will keep on traversing the loop in small subtrees as well. So that will be the whole idea behind this question. Let's just write this question, and then I will explain again how the particular answer works with what we are thinking of right now. Okay, let's do it. All right. So here you can see it's a 3ms solution. Like more or less, if you run it again, it might go down as well. So let's understand what we did and how it stands with our question. Okay. So in this, we find that here we are using another map to map our index, like the particular value of like in order array value with this index. Okay, and we use a pre-index just to note like the current pre-order index at which we are. Okay, just to note this pre-order particular indexes. Okay, now what why we took it as a global variable, just because we don't need to pass this variable again and again to our like this additional function that we used here, build called build. So we don't need to pass it, so that's why we used it as a global variable. Okay, but what exactly we did, we just initialize both the variables over here, and then we just build up like the total map over here, like map in order array with our like in order array elements with our index. So that's what we mapped, and then uh, we simply called our build function. What we did, we made the left being 0 and right being pre-order dot length, like the right total length. Okay, and we passed only the pre-order area. What else we are trying to do? If we are trying to see that if this left is greater than right, that means we are done with it. We just need to return it from here. Okay, and moreover, we just need to go ahead and write. We just find the root val, like current value being pre-order of index. Okay, particular 0th index for there, and next we increment this index just to keep it continuing for its next loop. Okay, so there's a pre-index plus plus, and then we created our tree node. Okay, the current node we created the root node, and then we just called it like added root val as its value to it. And on its left, we just built again called the build for with like pre-order array, and left being the left side, and on the right side we just made it like in order index dot get root val, like from in order this we just get a root val index and -1, so zero, like from 0 till the value we currently have, or to, like less than the our current pre-order index. Okay, and uh, and then we just created a right side of it, right side being we are creating a like we are just sending the pre as well, and then in order index dot get root val +1, just from our current value we just implemented our like from next value till the end. Okay, that was the idea, exactly what we were discussing in the question like previously. And then ultimately once we're done with this, we'll return the root. So that's how it actually works for the whole question, and that's how the question is all about. Okay, so I hope I can make you understand how this question works, and if you have any doubts, so make sure to comment them down in the comment down your thoughts in the comments, and I'll be happy to help you out with any of your doubts. Also check out the description for any required links and stuff you are given over there. Okay, so thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.